Hi everyone, let us discuss about solar photovoltaic system with its application. What is energy? Energy is often defined as the ability to do work. We commonly think of gas, electricity or other fuels, several different forms of energy including kinetic potential, thermal, gravitational, sound energy, and mass have been defined to explain all known natural phenomena. The first law of thermodynamics is that energy cannot be created, only transfer between states systems is electrically created. Solar energy. The sun gives off two forms of energy for free. Sunlight, solar radiations. This gives us both light and heat. Without it, no life could exist on Earth. Gravitational pull. Along with the moon's gravitational pull, is responsible for the ocean tides. Sun power. Incoming solar incoming solar radiations and which is absorbed by the land and oceans, and it is reflected to the atmosphere and reflected to the clouds and reflected by the earth's surface and radiated to space from the atmosphere and radiated from earth to space. Free energy. Our sun releases huge amount of energy. Our atmosphere and clouds reflects or absorbs about half of what it is directed at us. What hits the surface of earth in 1 hour more than equals to the total energy requirement for the earth for an entire year. The sun is responsible for 99% of all renewable energy sources: wind, wave power, hydroelectric, biomass, and solar. Even petroleum products originated from the sun. How do we harness all the power? How do we? It means how do we store all this solar energy? How do we take all the solar energy? The solar industry. Thermal, using sun's heat to generate electricity. Solar cooking, solar hot water. Photovoltaic, using solar radiation to generate solar electricity. Solar calculators, light meters, and photovoltaic cells. Photovoltaic, from Greek word phos, light, and volt, electricity. Solar cells are made up of silicon crystals, sliced thin and layered. Silicon is semiconductor. Electricity can be passed but with high resistance. Solar radiation pushes the electrons through. Solar cells, about the size of your hand, electrical contacts both front and back, positive one side and negative other side, covered with anti-reflective glass. Photovoltaic system, we can see a solar cell and it is the solar panel, and this is array. Photovoltaic system, this is a example how the photovoltaic system is set up. Solar panels, most efficient solar panels are available today. 30 to 40% average solar radiations is 1000 watts per meter square. Output of the panel would be 300 to 400 watts. Very costly, roughly $800 per watt. Usually used in space. Common efficiency rating for panel 16%. Much more affordable, cost of $4, $5 per watt. Install cost of system $7 and $9 per watt is common. Cost benefit analysis. Systems are sold on a per watt output basis. Far easier to do a cost beneficial analysis. First question asked by the salesperson: how much did you pay for electricity last year? Easy to obtain information on current electric bill. System is used to cover 70% to 100% of expected use. More is not better. Utility companies do not pay for extra credits only. Output of panels. Factors change the output of panels: intensity of light source, angle of light source, and panel temperature. Intensity of light. Relative strength of solar radiation. Strongest is the equator, and equator regions are strongest. Black dots represent the amount of sunlight needed to replace the Watt's energy use. We receive 6000 types of amount of energy used. Angle of light. Best output is when the light strikes at 90 degree to the surface. Orientation is usually south. Suggested the best angle for the output is the same as the latitude of the location. Summer and winter changes in the sun angle. Tackling the system are optimal. Temperature. High temperature will reduce the output of solar cells. Cool temperature are the best. Hot to touch is bad. Elevated installations are suggested with air circulation under panels. Even the playing field northern climes can still have effective PV systems because of cooler temperature. Inverter. Panels generate DC current. It's like a battery. Inverter changes the DC current to AC current and changes the voltage from 120 to 120 or 240 for home use. Inverter is used to change the DC current to AC current, and systems are tied into the home electric panel. During sunlight, if output is greater than home's use, electricity is put into the power grid. Electric meter will spin backwards. At night, electricity will flow into the house normally. This system is called grid tie system. Design. Many homes are designed for net zero energy use. Grid tie system still use energy at the night. Annual energy use is a net zero as panel output equals to total home use. Energy conservation is key to net zero design. Keyword sustainability: to live in the manner that is sustainable by environment.